Good evening, learners. My name once again is Mr. Paul Chilola, representing a learning platform called Black Slides Online Learning. It's a platform where you learn science subjects based on the Msce syllabus entirely for free. You don't have to pay for them. The only expense you are going to meet or incur is to buy yourself internet bundles in order to access the lessons on YouTube. So these lessons are basically available on YouTube, strictly on YouTube only. All right, so what you have to do is simply follow the link which is provided on the WhatsApp group, Black Slides group. Follow the link and subscribe to the channel so that you don't miss any lessons as they get uploaded to the site, to the YouTube channel. So this lesson we have now is by public demand by a group of learners on a different platform other than Black Slides, where I also teach. So I saw it befitting to share with my Black Slides learners also to access the lesson entirely for free. So welcome once again. In case you covered this topic, electric current, in Form 3, before now, it is an opportunity for you to relearn, if not to overlearn. You can learn it again and again and again until you master the basic concepts. Remember, in physics, we don't teach for memorization. No. We teach you for understanding of the key concepts. All right, so if in case you missed something when you were learning this in class, this is an opportunity to do what we call gap filling, to fill up the gaps where you might have missed. But if you have not learned this in school, in class, in a formal class, just follow on the video, learn everything, take notes where it is deemed necessary, jot down the formulae, all right? But you can also request the PDF notes, which I can gladly share with you for you to read in your own time. So once again, welcome. In case you have just joined us, my name is Mr. Paul Chilola, representing the Black Slides Online Learning Platform. All right, so let us look at the meaning of electric current. All right, let us define electric current. Remember, I always say, and I would like to say now, that in order to unlock the understanding of a topic, it is important for us to define that topic. In order to understand a topic, it is important to define the topic. Once you define the topic, it is easy for you to follow. Because you know beforehand, well in advance, what the topic means. So let's define the topic or the term electric current. What is electric current? What do we mean by electric current? This is not a new concept in secondary school. I think you also encountered the same term in Form 1, all right, where electric current is introduced. Even as early as the primary school, the same is also taught. Yeah, but maybe it depends on the level of difficulty. But the definition is basically the same as that which you encountered in Form 1, or indeed as early as primary school. Maybe Standard 8 or Standard 7, I'm not sure where electricity in primary school is taught, in which class. So we are going to define electrical current. Electrical current in physics is defined as the rate of flow of charge. The rate of flow of charge through a conducting path, which is called the circuit. So electric current is the rate. It's the rate of flow of charge through a conducting path, which is called the circuit or electric circuit. So please take note. So in the definition, we have words like rate. All right, so it's the rate. All right. So it's the rate at which charge flows. Flows where? In a conducting path. That conducting path is known as the electric circuit. So you can see there we have 3, if not 4 key terms, keywords within the definition of electric current. We are saying it is the rate of flow of charge through which a conducting path, or through a conducting path, which is called a circuit. All right. So suppose that we are looking at a path, a circuit. So given here in the figure is a circuit. It's a circuit diagram consisting of a cell. Remember what a cell does in a circuit. It provides the energy to be used to push the charge. So this charge is basically electrons. So when we're talking about a charge constituting electric current, such charge is basically electrons. So we are saying we have a cell. The use of the cell is to provide energy to the electrons, or to do work on the moving electrons. So the conducting path is made up of connecting wires. These lines represent wires. And then you have a bulb, you have a bulb, a switch, like that. So in short, we are saying, look at this circuit and go back to the definition. So we are saying electric current is the rate of flow of charge through a conducting path called circuit. So what we see here is a circuit. Suppose we close a switch. We close this switch there. We are going to provide, by closing the switch, it means we have provided a conducting path, in which electrons will be able to flow. So let's suppose we have an electron over here. So this electron will find a path. Once the switch is closed, you find a path through which it is going to flow. So electrons will flow like that. So if we consider the number of these charges, which are basically electrons, and the time it takes them to move from one point to another. Let's say, for example, we have a point A, and also maybe a point B somewhere here within the circuit, point B. All right, so we are saying electrons flow from point A all through the conducting path to point B, like that, back to A, and back to B, and so on, in a circuit like this, through the components that make up this circuit. Basically, they are the wires. The straight lines are the wires. Then we have the closed switch over here, a bulb, and the source of energy to push the electrons around, all right, which is the cell. So when the electrons are flowing, we also consider the time it takes the electrons to flow from one point to another. All right, so in order to determine the current quantitatively, you simply take the number of charges passing through a given point and the time taken to pass through it. All right, so when you divide the amount of charge by the time it takes, then you have the concept called rate. Rate means a certain quantity divided by time. So in this case, we are looking at the amount of charge flowing through a particular point and the time it takes. You divide the number of charges passing through the points divided by time. That will give you electric current. All right. So in a more correct way to define electric current, you have to mention the word rate. It's the rate, meaning it is some quantity divided by time. All right. So when the charge is flowing through a path, this conducting path, the circuit, don't forget the time taken for charge to flow through a given point, because you divide that time into the amount of charge passing through a particular point, and that will give you electric current. I hope you are good on the definition. All right. There are two types of current. There is what we call conventional current. Conventional current is simply current which is considered to be the flow of positive charges, which are called holes, from positive terminal of the cell to the negative terminal of the cell. Very important. So if you look at the cell in the circuit here, this is the cell. One end of it is positive. One end of it is positive. So we have a positive terminal this end, and the other end is negative. Make sure you know this. This is very important. Usually the positive terminal of the cell is marked with a positive sign, and the negative end is marked with a negative sign. So when we are looking at electric current, we look at it in two ways. The first one is to consider that there are more charges, positive charges, on the positive end, so they are going to flow from the positive end or through the circuit back to the cell, to the negative end of the cell. All right, so the charges which are assumed to be positive charges, there are more positive charges here at the positive terminal, so they will flow through the circuit back to the cell on the negative end of the cell. All right, so such current is called conventional current. Okay, it's very important to understand this one. But the real electron flow is from negative terminal of the cell to the positive terminal of the cell, as shown in this figure. So the real current, the real electric current, which is the flow of electrons, is from the negative end, which is this part here, all through the circuit. Mind you, this circuit ought to be closed. So this is closed. It's a closed circuit. This is a closed circuit, such that electrons will flow from the negative end of the cell all through this closed switch, through the bulb, and then back to the cell on the positive end. All right, this arrow here is showing the direction of flow of electrons. So strictly, when we are talking about electric current, we are not concerned, we are not talking about the flow of positive charges. No. we are basically talking about the electrons, the flow of electrons. That's why the direction, the real electron flow is also known as the electronic current, because it involves electrons. So electrons flow from the negative end to the positive end. The negative end to the positive end. The negative end of the cell through the connecting path back to the positive. So that's the real electron flow. So we are saying we have two types of current. Conventional current, which is considered to be the flow of positive charges, which are called holes. Mind you, these positive charges are not protons. No, they are not protons. They are holes. You will cover holes, more about the holes, in a topic known as digital electronics, when you are looking at a process known as doping. So just to wait until that time when you understand you learn more in detail about holes. So the real electron flow is from negative terminal of the cell to the positive end. So the examiner will ask you to draw a circuit, electric circuit, consisting of a cell, a bulb, a switch, and so on, and use arrows to indicate the conventional current. So all you have to do is draw an arrow like this and show the direction. So the direction is usually from the positive end. From the positive end, you can draw something like this. The positive end to the negative end. So we are saying conventional current is from positive terminal of the cell or battery, all through to the negative end. Or you can just use the arrow as shown in this diagram. You can actually draw such an arrow to represent the conventional current. Conventional current, this arrow here is showing you the direction from positive end to the negative end. This should happen when the switch is closed. Remember that current cannot flow through a gap, so this has to be closed. So current is going to flow. Conventional current is perceived to be like that, from positive end to negative end. The real electron flow, which is the real electric current, is from negative end like that to positive end of the cell. Very important to note. All right, again, this should be the case when the switch is closed, because electric current does not flow through an open gap or a gap. Very important. So we are saying we have two types of electric current. Make sure you know these. You are able to define conventional current, real electron flow. All right. So we are saying conventional current is simply the flow of positive charges, which are called holes, not protons. Take note, these are not the protons. Remember that protons are localized in the atoms, in the nuclei of the atoms making up the conductors. All right, very important. So these positive charges are not protons. I repeat, they are not protons. They are basically holes. We'll talk about holes in much greater detail when we are covering digital electronics. Once again, electric current, the real electric current we are talking about, is from negative end through the conducting path back to the positive end. All right, I hope we are good on this. So electric current is a quantity, is a physical quantity. Remember that we have 7 basic quantities in physics. All right. One of them is electric current. So if it is a basic quantity, it means there must be a means of calculating it when enough information has been provided. So we are saying electrical current can be calculated using a formula. There is a formula for calculating electric current. Let me ask you to be vigilant, to pay the best of your attention on this, because this is a mathematical formula which requires you to understand very well where it needs to be applied. All right. We define electric current. Electric current, current is equal to charge, the amount of charge divided by time. Remember, we defined the electric current as the rate of flow of charge. So the charge divided by time is basically a measure of the rate of flow, like how much charge passes through a given point in a given time. All right, the amount of charge passing through a point in a given time, that's called the electric current. So mathematically, we define current as the amount of charge passing through a point per unit time, or simply charge divided by time. I hope we are good on that formula. All right, or in short, using symbols, current, which is represented by the letter I, is equal to charge Q divided by time. Now, let me just say a little about the symbols you see in this formula. You see here, there's the letter I. Here, there's no I in the word current. Okay. Similarly, we are using Q for charge, yet there is no Q in the word charge. Where do you think the I and the Q are coming from? All right. Okay. Why the letter I for current, and why the letter Q for charge? So here is the deal. The letter I is used for current because originally the quantity which we call current nowadays was in French. All right, was in French. So in French, electric current is called low intensité. You'll pardon me, my French, not good enough. Low intensité de courant. Low intensité de courant. In French, current is low intensité de courant, written like this. Low intensité de courant. The courant, written like this. In French, current is called low intensité de courant. This is supposed to be an I. All right. So if you look at the word l'intensité, this is the intensity. Instead of saying the intensity, the in French is written as LE. All right, so this part is basically LE. So since there's a vowel in front of the L and also a vowel the vowel I in the word intensity, you put a apostrophe there and it sounds l'intensité de courant. So the letter I in the word intensity is the one which we borrowed to represent current. I hope we understand that. So the letter I in the word intensity. This, when interpreted into English, translated into English, is supposed to read the intensity of current. The is off. All right. So in English, it's supposed to be the intensity of current. So since the word intensity has an I in it, we take just that I and use it as a symbol for electric current. I hope we are good on this. While the letter Q is not appearing in the word charge there, but why do we use this one? All right. Instead of saying charge, sometimes we say it is quantity of charge. So quantity of charge. So instead of saying quantity of charge, we just say charge. But the word quantity has the letter Q in it, this one here. So we borrow that Q and place it there to represent charge. All right, so we're saying the letter I for current comes from the French word for current, which is l'intensité. So there's the letter I in the word intensity. So we borrow that and use it as a symbol there. Whereas Q is taken to be a symbol for charge, because in full, when you write charge in full, it's supposed to be quantity of charge. So we just write charge in short, but it's supposed to be quantity. So the letter Q is used to represent quantity. So the amount of charge passing through a given point in a given time will give us current. So you divide the charge passing through a point and the time taken to pass through it, and then divide the two, it will give you electric current. So usually charge is in the units. Charge is in the units called coulomb. So this one is in the charge. The unit, the SI unit of charge is the coulomb, while that of time is the second. So when you're dividing charge by time, you are basically dividing the number of coulombs by the number of seconds. Please take good note of that as well. So the unit of electric current is the coulomb per second, written in short as capital C / S, small s. So the capital C is short for coulomb, and the small s, is short for the second. So you are dividing the number of coulombs by the number of seconds. Therefore, the unit of electric current is the coulomb per second. Please take note that the charge that we are referring to is not positive charges. It is the negative charges. Okay, so together in a group, they are called coulombs. We'll see the meaning of coulomb later. So the SI unit of electric current is known as the ampere. All right. So when you are writing the unit in words, the A needs to be small letter and the symbol is capital letter. So what we are saying is, when you are calculating electric current and you find the number of coulombs per second, remember to leave your answer in ampere. 1 ampere is simply equal to current of 1 coulomb per second. Take note of that. So in your calculation, you find your answer in coulombs per second. So remember to convert that to amperes. Please don't forget to do that, because that's what the examiners will require you to do. So we are saying 1 ampere, a current of 1 ampere, the current of 1 ampere is equal to 1 coulomb per second. Please don't forget, in a calculation, you find the coulombs per second. So leave your answer in ampere, because 1 coulomb per second is equal to 1 ampere. So if they ask you to state the SI unit of electric current, it's just the ampere. Please don't just write the symbol, unless the question says state the symbol. So you have to write the name of the unit. State the SI unit of electric current. It is the ampere. State the symbol of the SI unit of electric current. It is the letter A. I hope you understand that. All right. So definition of an ampere is simply the amount of charge that flows through a point per second. That's how you define an ampere. So you're looking at 1 ampere. 1 ampere is simply one charge, a charge of a magnitude of 1 passing through a point in a second. So smaller currents are also called used in electric measurements, such as milliamperes. So 1 milliampere is the same as 10 to the power minus 3 amperes. Remember when you were learning prefixes of SI units in Form 3, in second topic in Form 3, or first topic, should be the first topic in Form 3, you learned about prefixes. So the prefix mil means 10 to the power minus 3 amperes. Just a reminder. All right, so this unit is used for very, very small currents. A mil is very small. It's the same as a mil is the same as 0.001 ampere. So instead of writing this, it is advisable to write it like that. All you do is you shift the number of decimals up to there. So you have 0.001 becomes 10 to the power minus 3. You also have other smaller units, such as microamperes. Micro usually is 10 to the power minus 6. So this is 10 to the power minus 6 amperes is the same as 1 micro. A micro is represented by a symbol mu, the Greek letter mu. All right. Very important to note these facts. They help you in your calculations in physics. So what are we saying? We are saying that in order to calculate current, all you have to do is divide the number of charge by the time taken, which is the charge is in units. Current is represented by the letter I, and charge is represented by Q, which means quantity of charge, divided by time t. Remember to leave your answer in SI units, which is called the ampere. An ampere is the same as a charge of or a current of 1 coulomb per second. I hope we are together there. And let's see, you have questions. If you have questions, don't hesitate to contact me on my number, on the number shown on the screen, to ask or seek clarifications. All right. Let's look at how we can determine the total current passing through a point in the circuit. The total current passing through a circuit, passing through a point in a circuit. So we are looking at a circuit, and then we want to find the total current passing through a point in a circuit. How can this be determined? To do that, we can have a look at this circuit here. This circuit consists of just two components that are connected by wires. So what you see, these lines here, so you have a cell here, this is a cell, and then you have a lamp, and then you have a conducting path. The rest of the circuit is just a conducting path. So you have, these are wires. The dots that you see inside are the charges, which are basically electrons. They are called free electrons. All right, so the electrons are flowing through the conducting path, the circuit. This will make the bulb light. Remember that where a cell or battery is connected, they are there simply to provide electrical energy to push the electrons around, to do work on the electrons moving around the circuit. That you should never forget. Very important. So consider this circuit. All right. If we let n, the letter n, to represent the number of electrons passing through the point A. So we have a point A here. So suppose the number of electrons passing through that point is n, all right? Okay, and that each electron carries a charge, E coulombs, all right? E stands for number of coulombs. Then the total charge Q passing through the point A is equal to NE coulombs. Get this right. We are saying that if any electrons pass through a given point and that each electron carries a charge, which is E, then the total number of charge Q passing through the point A is equal to NE, or N times E. Remember, we are saying N should represent the number of electrons, and each electron carries a charge E. So how many coulombs will pass through at that point, the point A? All right, so all you have to do is take the number of electrons multiplied by the amount of charge per electron. It will give you this number of coulombs. I hope we are together there. All right, so we can comfortably and happily write the equation Q, the amount of charge passing through the point A, is equal to the number of electrons multiplied by the charge per electron. That will give us the total charge, So we are looking at these many electrons, assuming there are n of them, where n represents a real number, by the way. It can be 1,000, it can be 2,000, it can be million, it can be anything. But each one of them carries a charge E, okay, in coulombs. So what is the total amount of charge? It's going to be the number of charge multiplied by the charge per electron. Now, if we go back to our equation of electric current, we said that electric current is the quantity of charge divided by time. So where there is charge here, Q, we can gladly bring down this. So this can come here to replace the Q, so that now our current is going to be equal to NE divided by T, NE divided by T. The N stands for the number of electrons, and the E is the charge per electron. So the amount of charge, therefore, is going to be NE. So the total current is going to be the number of charges divided by time. 1 electron of charge is equal to 1.6 times 10 to the power minus 19 coulombs. So assuming we knew the number of electrons there. To find the total charge, we would simply multiply that number by 1.6 multiplied by 10 to the power minus 19. Very important. So we shall use this equation, therefore, to calculate the total current. The total current. If we know the number of electrons and the charge per electron, which is 1.6 times 10 to the power minus 19 coulombs, we can calculate the total charge. The total charge. The total charge. I hope we are good on this. Unless you have a question, then you don't hesitate to either text me or to call me on the number that has been given. All right, having gone this far, let us appreciate this example. All right, the example is saying calculate. I hope you have a calculator with you. Please, if you not, pause the video, get your calculator nearby, and follow on the calculation. Then maybe the calculations may not be right. You can use your calculator to verify, and then let me know if something is wrong with the calculations in this presentation. So calculate the amount of charge that passes through a point in a circuit in 3 seconds if the current in the circuit is 0.5. Nice. This is nice. Right? So always I encourage my students to understand the question before they rush through solving it. All right? Look at the information given in the statement. All right? Look at the information given in the statement. Determine the data which is given there, the variables which are given, and that which is not given. And it is required to be calculated. So here you can see that we are given time. This is time. Actually, this is time, t. That's time, t. Remember the SI unit of time? It is the second, as shown there. And we are also given electric current. So we are saying the time is given, current is given, but something is hidden and it is required to be calculated. All right, so what is it that we are asked to be to calculate? All right, so we have current here, we have time, but there is no charge. Charge is not given, but it is also something that we need to calculate. Okay, so we are given time, we are given time, and we are given current. We are supposed to calculate Q, or charge. Right, so how do we set out our calculation? So remember that electric current, I, is equal to charge, the amount of charge divided by time. So are we given the amount of charge? Of course not. Okay, that's the one we are asked to calculate. But are we given current? Yes. So this is current and this is time. Current is 0.5. Time is given as 3 seconds. So all we have to do is to make the letter Q the subject of the formula. Remember, when you have current, we are saying current is equal to charge divided by time. So what is required now is what? Is the letter Q, the charge. So to do that, we need to make it the subject of the formula. Remember, subject of the formula, when you have a denominator down there, you simply multiply both sides by that denominator, t. So we have t there. You also multiply this side by t. So this t and this t are going to disappear, so that in the end, you have Q, the letter Q being equal to current I multiplied by time t. That's what we have right here. We are doing this because it is Q which is required to be calculated. It's required to be calculated. Very important. All right. Okay, so that said and done, let us now substitute. So the remaining part is just substitution. We are told that current is 0.5, while time is 3 seconds. Current is 0.5 amperes, and time is 3 seconds. So all you do now is substitute and then simplify. So you have 0.5 here multiplied by 3. So when you multiply 0.5 by 3, can you do it on a calculator? Let's see what you find. What is 0.5 multiplied by 3? Go ahead, calculate on your calculator, or otherwise find 0.5 multiplied by 3. What does it give you? What does it give? All right. So if you do your calculation correctly, you find that Q, which is the amount of charge, remember, the amount of charge is equal to 1.5 amperes, coulombs, 1.5 coulombs. Don't forget to show the unit, the SI unit. So charge is in coulombs. It is wrong to say charge Q is equal to 1.5 maybe amperes. No, this ampere is not for charge. It is for electric current. All right, so be careful there about the units. I hope we are good as well on this one. And let's see, you have a specific question. Then you can contact me, check where you don't understand. You can request for further explanation. Let's look at another example. In this example, we are asked how long would it take for a charge of 1,200 microcoulombs. Be careful here. This means microcoulombs. A micro, remember that a micro is simply 10 to the power minus 6. Right? So this is the same as saying 10 to the power minus 6 coulombs. Okay, 10 to the power minus 6. Okay, I want you to understand this. This one is, we are saying 1,200 microcoulombs is the same as 1,200 multiplied by 10 to the power minus 6 coulombs. So this 10 to the power minus 6 is that. Okay? Because if you don't interpret this symbol as 10 to the power minus 6, you are going to get a wrong answer. You are going to get a wrong answer. You are going to get a wrong answer. We don't want you to get a wrong answer. So we are saying, how long would it take for a charge of 1,200 microcoulombs to flow when a current of 0.01 ampere is flowing in a circuit? All right. Once again, you have to determine what is this. This is charge, coulomb. It's charge. And what is this one here? This is current, I. So the question is saying, how long? How long? What does how long represent? How long represents time? How long represents time? How long represents time? So you have QIT. Remember that QIT are connected by the equation I is equal to Q divided by T. All right, so current is given, charge is given. What we don't know is time. Okay, so again, using your knowledge of change of subject of formula, you need to solve for t. Then it will give you the time taken for that amount of charge to flow through a point when the current is 0.01. All right, I hope you understand that. Okay, so the formula, from the formula Q equals to IT, which is derived from I equals to Q over T, we make T the subject of the formula. So making T the subject of the formula is going to give you T equals to Q divided by I. Careful there. So we are saying Q, since Q is equal to IT, Q is equal to IT, or current times time, we want to make T the subject. So to do that, we have to divide both sides by I. Remember, an operation done to one side of the equation should be done to the other side as well. All right, so the I here is common. You cancel that. It will give you, you end up getting T equals to Q divided by I, as shown here. All right, since we know I is 0.01, and we know Q is 12,000 microcoulombs. So all we do next is to substitute. So you substitute. Don't forget to show the real value of the micro. So we have 12,000, which is given here. Sorry. The 12,000 is given. And then in micro, we said the micro is 10 to the power minus 6 coulombs. You divide by 0.01. 0.01. Using a calculator, if you punch this carefully, you should be able to find, something like 0.12 seconds. So this one represents the time it takes for the charge of 12,000 microcoulombs to flow through a point when a current of 0.01 amperes is flowing through it. Another example, find the amount of current passing through a point if 600 coulombs of charge flow through it in 4 minutes. This is another case where you need to pay attention. Remember, the definition of electric current, I, is equal to amount of charge passing through a point in a unit time. That's what you know. So this should be in coulombs. Always remember that. This is coulombs. While time is in seconds. So this definition is true if and only if the charge is in coulomb and the time is in seconds. But look at this case here. We are given time which is in minutes and not in seconds. That means there's more to be done than just taking dividing 600 coulombs by 4. So you need to convert the minutes that are given into seconds. Then you proceed with your calculation. All right. So using, once again, the formula, current is I divided by, is I equal to Q divided by T, or current is equal to I, current is equal to charge. So this is charge. Okay, this is charge, and divide this by time. All right, divide by time. Okay, so substituting, don't forget that the charge is already given as 600 here, but the time is in minutes, not in seconds. So you know from your basic mathematics that 1 minute, every 1 minute is equal to 60 seconds. It's equal to 60 seconds. So what you do is you have to convert the minutes to seconds. In order to do that, you simply take the 4 minutes which are given there, multiplied by 60 seconds, because every minute contains 60 seconds. What about 4 minutes? So it will be 4 times 60. Make sure you know this. You know how to convert times from hours to minutes, from minutes to seconds, to microseconds, to milliseconds, and so on. Make sure you know that. Right. So in this case, you multiply, you divide 600 by the product of 4 and 60. It should give you 2.5 amperes. Don't forget again that you are dealing with current. So current is supposed to be in the units of amperes. So suppose you are doing this in an exam. Sorry. If you are doing this in an exam, marks are allocated for correct formula, correct substitution, and the answer. So such a question like this will award you 3 marks. So 1 mark for the formula, another mark for substitution, correct substitution, correct substitution, correct substitution, also 1 mark, and the final answer is also worth 1 mark. So don't forget, this is the working out. Once again, this is example has given you an additional skill of converting time, which is not seconds, to seconds. So 4 minutes change to 4 seconds. You just multiply 4 by 60, then it will give you the what? The answer, the result that you are looking for. Don't forget once again to subscribe to the channel so that you don't miss on the lessons as they are being uploaded. All right, so we've come to the end of the lesson today on current, electric current. And I would like to leave you with some work to do based on what we've discussed today. Great. So number 1 is asking you to calculate the amount of charge that passes through a point in a circuit in 3 minutes if current in the circuit is 0.5. So you have current, you have time, but it's not in seconds. Remember to convert into the right units, in this case into seconds, and then you proceed with your calculation. How many seconds would it take for a charge of 1,200 microcoulombs to flow when the current of 0.01 ampere is flowing in a circuit? This is supposed to be a question, so you must have a question mark there. All right, so I'll be looking forward to receiving solutions to these questions when you've completed them. Otherwise, thank you very much for your attention. I hope you have learned something. Keep checking for new videos as they are being uploaded. You can also request these special topics that you might not understand in school. I'll be more than happy to prepare lessons for the same and present them to you. So once again, in case you have questions, feel free to contact me on the numbers shown here. Both numbers are on WhatsApp, so just text me, ask me if you need any help, I'll be more than happy to assist you. For now, thank you very much. Take care of yourself. Bye-bye.